All right, hey everyone, I'm back with another tutorial. In the past, I've shown you, if you look back at my videos, I've shown you ways to make custom threads using the Coil tool. And this is for 3D printing. So there is another way to make threads in Fusion 360, and they actually have a thread tool. Now this can be a little bit more finicky when trying to 3D print something with these threads. Just because they're a lot smaller and a lot more compact. But I'm going to show you my method on how I create 3D prints using the thread tool. And again, I'll just make another little container like I've been doing for the last few videos. And then at the end, we'll 3D print it and you can see how well it works. So here we go. I'm going to create a very, very simple jar container. I have gone through this in the past, so I am not going to give you too many instructions, but we'll just go, I don't want to make a big jar because I'm 3D printing this. It doesn't need to be huge. We're just testing the threads. Cancel. Let's go to another cylinder. This will be the threaded portion. Let's just do 55 for this one, and we'll go up 10. When making a jar like this, you want to use the shell command and hollow this out before you make the threads. Otherwise, the shell command is going to try to follow the contour of those threads on the outside, and it's going to do a really bad job. Now, that will work if your walls are thick enough. Usually my walls, I keep at like 2 millimeters, so there's no sense in following the shell command with those threads. I just keep it nice and flat on the inside. So I'm going to set up a section analysis. So if you go to inspect and go to section analysis, this little window comes up and it's asking for a cut plane, basically where you want to slice this model in half. And you're not really slicing the model in half, you are just doing an analysis of it. So I always like to kind of stay in front. So I'm going to click that front plane and you can see it did it backwards and that's fine. But now my OCD kicks in, and if you look up here, now we're facing the back, and I hate that. So you can flip it right here, and there's lots of other things you can do in this section analysis. You can rotate it. I mean, you can move it however you want, right? You can move it further out, but I like it right in the middle. So I'm going to hit OK. And if you go over, here's the section analysis. You can turn it on and off, or if there's just one, you can click that. So here's my basic jar. I'm going to do a quick chamfer here because we are going to 3D print this. I know from experience this is 2.5, and actually might be like 2.4. Let's keep going down, 2.3. Yeah, let's just keep it at 2.5. It doesn't matter. And that just strengthens this bottom connection when you 3D print, and then gets rid of this overhang here. So this will 3D print nicely. So if I turn the analysis off, there's my real small jar. Okay, so let's do the threads. And to use the thread tool, first you want to click on a surface where you want to create the threads, which is this outer surface right here. And if we click on this edge that's highlighted in blue now, you can come down, and it has a 55 millimeter diameter. And so that'll give us a good starting point of where we want to create, of the size we want to create these threads. So I have my face selected. We go to create threads, and you can see it doesn't look great right here. So you're going to go to modeled because you want to actually see the threads. And this is where you're going to have to play around with stuff. And this is where this analysis becomes important. If we turn that analysis on, you can see these threads cut into the thickness of this little threaded portion that we created. And you could try to go down to like M2 or M55, what is this, 2 millimeters. And that is a little better, but that might be a little thin here when we print this. So what you can do is bump this up to 56 millimeters, and then we'll go down to like an M2. And now you can see that's definitely a lot thicker. Usually when I use the thread tool, I never go past M2. I actually really like to be in the M3. M2 will work just fine. You just may have to increase your allowances a little bit. I have found that the bigger the thread So M5.5, M4, the larger the thread, the less tolerance you need. But I tell you what, we're just going to go all the way down to an M2 because that seems to fit this jar pretty well. So I'm going to hit OK. And if we turn analysis off, there's our threads. And if we turn analysis back on, you can see we have plenty of thickness here. So this will be a strong enough print. Okay, here is a great trick for using these threads. If you were to just to leave it like this, if we go to the front view, you can see it has this little lip here, this very sharp edge. And that makes it difficult to thread your lid on because this harsh ledge just kind of gets in the way. And so we can kind of trick Fusion using the chamfer tool. Now we wouldn't be able to go up and use the chamfer tool like this because there's just, I mean, you can, I guess, for a little bit. Let's go back to equal distance. I think it's probably going to throw me an error. Let's do like 1 millimeter. Yeah, see, it's throwing errors because it's not one continuous rim. So we can trick Fusion a little bit here. So in your history, in your timeline here, we're going to go back. So you click on this. This is kind of your marker where we're at currently. You can click and hold and then drag to before we made the threads. And now we can click on this edge, go to chamfer. And usually when you go to chamfer, it's set to equal distance. So you only set, you can click here 1 millimeter and you can see I added this little chamfer here. And I tell you what, let's see how well that'll work. Just so this will be the easiest way to do it. So we'll hit OK. So now we can go back to our history down here and drag the threads back or drag the history. And you can see that kind of messes that up. That doesn't look right, right? That's not gonna work very well. So what you can do is take this feature, that chamfer we made, click and hold and drag it to the other side of the threads. And now it added that chamfer with the threads in place. And you can see that difference it made. And let's see if we have any harsh edges. So let's just spin it. And look, we have no harsh edges. Maybe just the tiniest bit right here, but that is so much better than before. And you know what, you might even be able to chamfer this. But we're not gonna worry about that. So that is a great way to make these threads work better. And it's super simple to do. So there you go. Now we have that nice chamfer along this edge. Okay, let's make the lid. So to make the lid, we're going to create another cylinder. So I'm going to create cylinder. I want to start the lid right on here. That's right where it's going to be seated when the lid's fully closed. So drag out from the center, 60 millimeters. And we don't want to cut, we want a new body. So we'll make sure we have new body selected. And we will go up to, you can see the lid is at the top of the threads. And we need some thickness on the top of the lid, of course. So we'll just do maybe like 13 millimeters. And we'll hit OK. And so if you go to body here, we have, we'll name this real quick. So this will be the base. And this will be the lid. So if we hide the base, we just basically have like a hockey puck, right? So we're going to use the cut tool or the combine tool to cut out the threads that we've created in the base into the lid. So let's go to combine. And when the window pops up, the first thing it wants us to do is select the target body. And the target body is the body in which we want to do something to. Like we want the action to go, we want to cut something away from the lid, right? So that's our target body. The lid is our target body. And I think I selected the base. So if you see how the base is selected, and I don't want that. So let's hit the X. It's highlighted in blue here, so that's the target body. So let's just click on lid. And now you can see it's moved down to tool body. The tool body is the base because we want the threads of the base to cut into the lid. So the base is now acting like the tool. So we can just click on the base and you can see whenever something is in red, that means it's cutting. And And right here is where you can select cut. It may be on combine, and you can see everything disappears now because it's trying to combine these the base and the lid, which we don't want. Intersect means it's only going to keep the part of the two bodies that intersect each other. So we don't want that, we want cut. And you want to make sure you keep tools in this instance. Now remember, the tool is the base of the jar. And if we were to keep this unselected, when it made its cut, the base would disappear, the tool would disappear, but we want to keep the base. So make sure that's checked and we hit OK. And now you can see if we turn the base off, we have the lid. And of course, we've got this funky part in the middle, which we don't need, and that's really easy to get rid of. Select this face, and if you're wondering, just to remind you why we're only seeing half of the lid, it's because we have this analysis turned on, so we can kind of see what's happening in the middle, and you can toggle that on and off. A lot of times I'll just work with it on just because it kind of gives me a better picture of what's happening. So I'll keep analysis on, and let's get rid of this little inner section here. So click on that face, hit E on the keyboard for extrude, and instead of typing something in or trying to drag this and guessing, even though it's 10 millimeters, that's kind of the default, which is exactly what we want. If it wasn't that 10 millimeters, if it didn't work perfectly like that, you can just click on this face and it'll snap to it. And we do want to cut. So cut is selected and we hit OK. And there you go. Now that middle section is gone. And if we turn the base back on, we can see it has made a perfect cut. Now, of course, this isn't going to work for 3D printing because there's no allowance here whatsoever. And so this is how I create allowance in these threads. I usually shoot for between 2 and 3 millimeters, or I'm sorry, 0.2 and 0.3 millimeters of interference or allowance. And depending on the size of the jar, obviously the bigger the jar you get, the more allowance you're going to need, right? Because the 3D printing the 3D printed part is bigger, which just means there's going to be more air. The print isn't going to be as accurate the bigger it gets. So if you're creating a really large jar, you may need to bump up that allowance to like 0.4. But I actually do a combination, which I have found works best. So I'm going to do a combination of 0.3 and 0.2. And so if we hide the base and turn on the lid, you can see there's tons of thickness here. Actually, here's something good to cover. You can see the lid has way more thickness than the base. So when we create the allowance, we want to take away material on the lid side, not the base side, because we want to keep this as much thickness as we can. If we start hogging away material, this is going to get really thin, and you can just see how much more thickness we have on the lid. So let's hide the base, and we can start selecting these faces to make an offset. And so the easiest thing to do, if we just decided we want to do a 0.2 millimeter allowance, is you click on a face, you can hold Shift and click on all the other faces, and that will group select everything. And you really want to make sure everything is selected, and it looks like it is. Actually, I don't know if this looks like we had one piece that wasn't selected, so now it is. So we have all of the thread faces selected. And so let me zoom in here. The tool we want to use is the offset tool. So we're going to go with all of these faces selected. We're going to go to modify, offset face. And where's my little arrow? I want to make sure that's visible here. There it is, over here. So if we type in 0.2, if you see the direction of the arrow, it's going to offset the face in the direction of that arrow. And so we're going to have to do negative 0.2 because we want it to go in the opposite direction. So if we type in negative 0.2, there we go. I don't know what that little funkiness was there for a second. So negative 0.2, let's hit OK. I'm not sure if we just got an error there. Let's take a look. Nope, we got it right. So let me get back to the front selection. I'm going to hit home real quick, and then we'll go to front. Sometimes Fusion 360, if you notice that your like scrolling and zooming in is starting to act like funky and really slow, you can reset that by just hitting the home button. And that will kind of reselect things and start making things move faster again. I don't know why that does that. I don't know if it's a bug with my computer or a bug with Fusion, but that's a good way to fix that if you notice your scrolling and zooming is just getting really, really slow. So let's turn base back on, and there you can see we created that allowance. Now before I was saying I was going to do kind of a combination between 0.2 and 0.3. And so we have created 0.2 millimeters here. And let me just make sure I did this right. I hope I didn't have to have it. Okay, so I shift clicked it and selected both faces. And if you go down here, the distance is 0.2 millimeters. So we did that correct. Now, if we think about this as a real physical object, what are the points in here that are actually gonna, I may be thinking about this backwards. So if I am, let me know in the comments. But the way my brain works is if this is a really 3D printed part, these little points here, these sharp points on this side and this side are going to be digging in to each other, right? Like this point is going to be digging in here and causing friction issues. And gosh, now that I'm thinking about this, it might be the opposite. Maybe this causes more friction, right? Because this is a bigger area. So you decide what you want to do. But since everything is 0.2 now, I am going to create more allowance on this edge. So I just clicked that point edge. I'm going to go to modify, offset face, and I'm going to go to -0.1. And as long as my computer doesn't blow up, there we go. So hit OK. Sorry, I don't know if you saw that happen because my computer kind of froze there for a second. So now you can see just on this face and this face, now it's 0.3. And so now we can do the same thing with this point. I can hit, oh, I'm sorry. We want to stay on the lid, remember. So I don't want to, I guess I could do it from here, but since we're sticking with the lid, we shaved off 0.1 on the lid side, so I'll do 0.1 on this side. You could shave 0.1 off the base instead of the lid because there's lots of meat here, but we'll stick with the lid. So we're going to click on that face, modify, offset, and then you can see the arrow here is pointing in the inward direction, so we have to do a -0.1. And it's given me an error. Don't know why it's giving me an error. Now the arrow changed in the other direction, so let's just hit 0.1. And we're getting an error again. So maybe that has to do with that chamfer I created. So we'll just go on the base. It doesn't really matter. So let's go modify, offset, -0.1. There we go. Hit OK. See, when I do these live videos, not everything works as it should, but you just play around with it till you get what you want. So now if we reset our view, go to front view and zoom in. Now you can see I have 0.2 millimeters between these flat surfaces and 0.3 millimeters between the ridges. And again, I may be thinking about this incorrectly. I might have needed to keep this distance at 0.2 and keep these flat areas at 0.3, but I think this is how I normally do it. And that should give me really good tolerances for these threads. And you know what? We're going to find out together because I'm going to 3D print this. So let's add a quick chamfer here and we'll hit OK. And I'm not going to do anything else to this. If you import this as an STL, it probably depends on your slicer. You may want to orientate, I'm not sure, I can't talk anymore, the parts so they are on your slicer bed correctly. So I'm going to move this lid. I'm going to rotate it 180. I'm going to move it off to the side, make sure it's not touching. We'll go 65 millimeters. Hit OK. And then another cool tool you can use is the align tool. So I'm going to align this base with this base, so it just puts them on the same plane. Hit OK. And now with Fusion, you can go up to your browser here where it shows your whole model, and you can right click, save as mesh. And the format is STL. If you were doing like a color print, you would want to choose 3MF, so it would save certain bodies and features so you can color them. And I already have my Bamboo Lab slicer selected, so I can send it right to my print utility. So I will hit OK. And it will send this to Bamboo, so give it a second here. And I don't want to update right now. Okay, so there is our model, and it's perfectly uploaded into Bamboo. Now I have a P1P. I also have a P1S. We'll stick with the P1P. I'm pretty sure I have PETG. I guess, you know, one thing I should talk about, PETG usually works better for threads. I have found that it's a lot smoother after it's printed, where PLA almost feels grainy. So that might be something you want to consider when you're figuring out what allowances you want to make on your jar. If you're using PLA, basic PLA, you might want to do 0.3 all over. If you're using more of like a textured PLA, I'm losing my train of thought, like a shimmery or whatever. I can't remember what you call it. You may want to increase that allowance in the threads that we made, because you might have inconsistencies in that PLA with the shimmery or whatever. But since I'm going to do PETG, I almost feel like I should just do PLA, since I feel like that's what most people are going to be printing. I will do PLA. So I'm gonna click on this and switch it to my PLA. And then maybe if this doesn't work, we'll see. Because I'm making this video live. I don't know what I'll do yet. But if this doesn't work great, maybe I'll print it in both. Maybe I'll print another one in PETG, and we can kind of compare with those allowances. But okay, let's send this to the printer. I will stop the Fusion 360 portion of this video right now, and I'll be back with 3D print. Let's test this out. Don't mind the huge mess. I have not taken this off the plate yet. And let's see how this threads. Okay, here are my two parts. There was just a little bit of stringing on the lid, so I did remove that, but otherwise I've not done anything to these threads at all. So here we go. Let's try to see if we can thread them in. Lots of twists, and then there you go. And what I have found with 3D threads is, once you use them a little bit, once you thread this in and out a few times, it just gets easier and easier. You know, the plastic rubbing on each other kind of smooths those layer lines out, and it gets a lot smoother. I probably needed less threads here, because geez, you got to twist this thing like, I don't even know, 1, 2, 3, 4. You got to twist this like 6 times to make this work. So when you're using the thread tool, especially for 3D printing like jars and containers, you don't need to have this tall of threads. But there you go. That's with a allowance of 0.2 millimeters and then 0.3 millimeters on those ridges, and it works great, and everything printed really well.